Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying a session. We are enjoying a lot. We are learning a lot. Hope the same thing for you guys. So, guys, if you come to this session, please make sure you guys watch all the previous session videos so that you guys can have a better understanding of what we are talking. Okay, so today's session is going to be a coding session of t-SNE. So last two sessions we have explained you what is t-SNE, what is the black box behind that t-SNE, what are the how it works, what are the advantages of t-SNE, what are the limitations and challenges we are having in t-SNE. Those things we have explained you in the last two sessions. If you guys missed the session, please watch the last two sessions in order to come to at least to this session, because like it's a coding session of t-SNE. You guys need to know the black box behind it. Okay, and one more thing guys, if you guys doesn't subscribe to our channel, please subscribe to our channel, because like every day we are just posting a new video. Okay, subscribe and press the bell icon so that you will not miss any of our video, because like you will be getting notification whenever we are uploading a new video. Okay, so yeah guys, without wasting any time, let us dive into today's session. Okay, so today's session is all about a coding part of t-SNE. Okay, so first thing first, we're gonna import the necessary libraries. Okay, you guys know, right? The numpy is used to perform the mathematical operation, and before that, it is the collab environment. Okay, I hope like if you guys watched our Python session, you can know go through entire walkthrough of this collab environment. It is offered by Google. So Google is offering this, but like it's a online where it's an online ID where you can run the Python. So that's the thing. So guys, if you need more information about this, please make sure that you guys watch the coding session of Python so that you can have a better understanding of this IDE. So I will say in a simple manner, it's an offered by Google. It's a collab environment where we're gonna run our Python code. That's it. Okay. So moving on, let's go. Let's now really jump into today's session of coding part of TSN. Okay. First of all, we're gonna import the necessary libraries. Okay. NumPy, which is used to perform mathematical operation. Pandas is used to perform the data in the form of a data set, like a data frame. Matplotlib is used to visualize our data in a form of a static visuals. Datasets, we are gonna load brisk cancer dataset, and for pre-processing, we are loading the standard scalar. Yeah, from sklearn dot main manifold t-SNE. So we are getting from sklearn, we are just getting the t-SNE. Model solution trace split. Okay, now I'm gonna load the model. Load the dataset, load breast cancer dataset. So cancer.data, it is gonna be my x, and then cancer.target is gonna be my y. So cancer is gonna be the entire dataset you guys see here. So we are having something like data, and then we are having target value 0 and 1, and then we are having the target value malignant and benign. So it's a two different kinds of cancer type. Don't ask me what is it, how it occurs, what are the different things, because like it's completely related to medical field. Actually, before going for this, we guys need to know what these things are. Okay, as I'm mentioning, right, data science is not a standalone field. It's gonna help all the fields there. So whenever you're working on any project, you guys need to have a domain knowledge so that you can apply any data science on top of it. Since it is a toy data set, I already know benign and malignant or a type of it's a type of cancer type. One is very serious. I think benign is somewhat less serious when compared to malignant. So yeah, this kind of knowledge you guys need to know before going for this data set. So yeah, and then the data points, the features that we are having, right? It's gonna say how much radius the cancer is, what is the thickness of the cancer, and how deep it is. Like those things, it's gonna say. Okay, so that's the reason I'm just asking you guys again. Whenever you are working on a data set, you guys need to know the background of the data set as well as the domain knowledge of the data set so that you can completely work on it. Okay, so since it's a medical data, you need to have an expert in the medical field so that okay, these are the things that we need to consider while working on this data set. So yeah, so moving on, yeah guys, so let me share my screen again. Okay, wait a minute. Okay, yeah, so yeah guys, so hope my screen is visible. Yeah, okay. So yeah, as I'm explaining, right? So whenever you are just to the field, any field that you are working on, any domain you are working on, you need to know exact what the domain is so that you can apply on top of it. Okay, we are just explaining you, right? This is x except the target value y, which has a target value of 0 1, that is many and malignant, and then we are having summarizing our data set. So I'm just passing the x, that is only input to the data frame, and then I'm just passing the column names by using the cancer.feature names, where you're going to have the column names. I'm just describing it by using the dot describe function, and then I'm just printing the shape, that is df.describe and the df.shape. You guys see here the count of each and every record. Okay, like for mean radius it is like 569, and then mean texture 569. I hope like all the things that we are having, right? So all the features whose count value, min value, max value, min, and then 25%, 50%, 75%, but we can easily get by using this describe function. What is this, guys? Count, min value, max value, standard deviation. What is this? It's a descriptive statistics, right? We're just getting by using simple thing, simple function, dot describe, that's it. This is our data frame name, and I'm just passing it and just calling it dot describe. And then let's see the shape. So we are having nearly like 569. Okay, 569 is the number of rows that we are having, and then 30 number of columns that we are having. Okay, so this is all about this data set. Okay, hope you guys are able to understand, right? So now what we have done till now, one is we have done importing necessary libraries, then we have loaded the data set, that is a breast cancer data set, and we have gone for a summarization. Okay, hope you guys have understand. Okay, now moving on, let's see the pre-processing step. Okay, what we're going to do means we're going to apply the standard scalar. Okay, standard scalar, I'm just applying to a variable called a scalar dot filter transform for input, that is my x. Okay, so that we can get everything in a form of a scaled form. Okay, so you guys see here, so we are having the data in a form of some scale. Okay, here earlier we are having data in different scale, right? Here see here we are having data in different form, like we are having data in 0 point, and then there is some 16. So we are having data in different kind of digits. Let's put in simple manner. Okay, 2-digit number, 3-digit number, 5-digit number, like that we are having. But like once I apply the standard scalar, what happens means now you see here all the data is into the range. I think here it is okay, -7, -8 to 8. Okay, it becomes a standard scale. Okay, why we are doing it? I hope like if you guys are watching our video for the last 2 to 3 months, you guys now able to understand, yeah, this is why it is happening. Okay, consider as a human being, we are having a 3-dimensional data in one column, and then 2-dimensional data in one column, and then 1-dimensional data in one column. We give high importance to the column which has a 3-dimensional data. Okay, 3-digit data. Okay, that's the reason that same thing applied to this model. Model will also consider the 3-digit data is going to be more important when compared to the single-digit data. That's the reason we are just making all the data to a same scale, that is some -1 to 1. Here it is -8 to 8. Okay, like that. Okay, it will automatically do. Okay, that standard scalar function will automatically do. You guys doesn't need to worry about anything. Okay, now so you guys see here, this is our actual data. You guys see here it is like 7, like that. There is no negative value, but like once we add the scaled data, there are some negative values also, because like it is scaled from minus value to plus value. Now I'm going to split my data set to input and output. Okay, train test split. What is my x scale? Though this is my input. Okay, instead of x I'm just using x scale. Why is my output? Okay, I'm just giving my test size as 0.3, and random test is what it is, you guys know, right? Random test, whoever runs this notebook, they're going to get the same output. Okay, now you guys see here, this is the actual data set size. We are having 569 records and 13 columns. Why also we are having 569 records? Because we're going to have only one column in y, right? Whether it is malignant or benign. Okay, now I'm going to print the shape of now what is the shape of train and test, because like we have given 30% of data to testing. Now see what is the shape of it. So for training we are having nearly like 398 records. Okay, and for testing we are having 171 records. Okay, that is 70:30 split. Okay, hope you guys are able to understand. Okay, so now I'm going to apply the t-SNE. Simple, just t-SNE n components. I need only 2 components. Okay, how many features that we are having? Let's see the shape of the column. Okay, from the 13 features, Okay, see, we are having 13 dimensional data. Whether we are able to visualize it, no, right? It is not at all possible. As a human, we are able to see only 3-dimensional data. More, like, okay, but like more visibly, we can see 2-dimensional data that we can plot by using matplotlib. So what I'm going to do means, this 30-dimensional data I'm going to convert to only 2-dimensional. Let's see how we are doing it. Simple. Okay, let's see how we're going to do it. Okay, I'm having this X train, that is my training data. Before that, I'm just placing t-SNE n components equal to 2. That's it. Okay, um, just n components equal to 2. Okay, I'm just converting a 30-dimensional data only to 2-dimension. That is 2, n components 2. Now t-SNE x t-SNE dot fit transform of x train, that is my training data. Okay, I'm going to pass it. Let's see, x t-SNE. Now you guys see here, we are having only 2-dimensional data for the entire x train. Okay, only 2-dimensional data. All data are converted to 2 dimensions, the 30-dimensional data. You guys see here, this is my training data, first data. Okay, let's get a sample. Okay, x train of 0, where we are having 13 features. You guys see here, 1 2 3 4 5 5 1 2 3 4 5 6. So 6 into 5, it's 30, right? First data set, first data point, which is represented by 13 features. Once I apply t-SNE onto it, it just converted to only 2 features, guys. See here, x train, it is x t-SNE. Hope you guys are able to understand, right? We have reduced the dimension of 13 features only to 2 features, such that we can do the visualization on top of it. Okay, let's see. Now this is my x train. Okay, we are having 1 and 0, which is menin and malignant. Now moving on, let's visualize it. Simple thing, let us visualize it. Okay, x t-SNE, because like we're going to visualize by using only 2 dimension, right? We are having x t-SNE, which is reduced dimension of 30 dimension to only 2 dimension. Again x t-SNE, I'm just using a scatter plot. X t-SNE 0th dimension, that is the first dimension, and then first dimension. 0th dimension is the first dimension, this is second dimension. 0 means 1D, 1 means 2D, and then I'm just passing the color as white rain. Here we are having white rain, right? Whether it is melon and malignant. Okay, now I'm going to give the X label, which is just like first t-SNE component, and Y label, which is going to be our second t-SNE component. Now I'm going to print for the training data, and then I'm just showing it. Guys, see here. Okay, hope you guys are able to see it. Okay, in x-axis we are having first t-SNE component, in y-axis we are having second t-SNE component, and you guys see here t-SNE of BIS cancel direction for training set. Okay, guys, see here, guys, we are having 30-dimensional data. We have converted to only 2-dimensional, and you guys see here, we are having only purple color. This belongs to one class. It doesn't know what class, because like it's unsupervised learning, right? But it is one class, and this yellow color is one class. Guys, now see how much this t-SNE works. Okay, when I get to know about this algorithm first, it surprised me actually. Okay, because like TCA and LDA, they works for a linear data, and the accuracy of it is somewhat lesser, I will say. Okay, but and it is not able to apply the non-linear data for the PCA and LDA. But t-SNE, using a simple, only single line of code, we are just passing our data to the t-SNE. Now you are getting the value that is like this kind of visualization, which is like awesome, right? Because we have reduced the 30-dimensional data, only 2-dimensional data, and we are now able to visualize it. Okay, now you can see what are the representations that you can take from it. Okay, lower thing, okay, we can consider it is a zero category, that is menin. Upper is malignant, that's a kind of cancer. This is the kind of cancer, that's kind of cancer. Sometimes the low important cancer is also some data points which is matching here. Okay, the model works fine, but somewhat there is some deviations. Okay, so and one more analysis, there are some outlier, and we will say mismatch, not outlier. Mismatch, outlier means it's completely different. Okay, it should be here, and it should be different color. Okay, when you get something like third class, because like we are having melin and malignant, when you have some other class which is very distinct, then it is called as outlier. But there is some misclassification, right? There is some purple which is combined with this yellow. Okay, so that is what we can say these things. Okay, we have done for the training data set. Okay, let's move on to the test data now. I'm just using the same thing, t-SNE fit transformer. I'm just passing the test data, that's it. And now you guys see here, for the test data, these are the features that we are having. You guys see only 2 dimension. Test data also we are having 30 features, 30 dimension. Now only two dimension. Okay. Now this is what the first test data that we are having. That is 13 features test data, only one data. For the one data to represent, we are having 13 features. Whereas once it is applied to t-SNE, we are having only 2 dimension to represent that same data point. Okay. Now this is the test set result. Now I'm gonna visualize it simple way. I'm gonna apply the scatter plot, test t-SNE of test data, t-SNE of test data. I'm gonna pass the first dimension here, second dimension here, that is 0 and 1, and the color should be x test. This is where the x test is. Okay. I'm gonna plot the x-axis is gonna be the first t-SNE component, y-axis is gonna be the second t-SNE component, and we're gonna have the title which is like t-SNE of breast cancer dataset. Okay, and this is for test set. Guys, see here, we are having first t-SNE component and then second t-SNE component, first t-SNE component in x-axis, second t-SNE component in y-axis, and this is what the title x t-SNE or t-SNE of breast cancer dataset for test dataset. Guys, see here. Now also we are having the purple color in the underground, that is like malignant, and then we are having benign in the top. Okay, benign and malignant, anything. Okay, only we are having only 2 classes. Okay, now you guys able to represent, right? We are having a low dimensional data, 30 dimension only to 2 dimension, and we are able to extract the features also. Okay, you can see here, like we are having this kind of data set here. Okay, this thing belongs to one class, this thing belongs to another, and there is some mismatch. And I will not save the mismatch here, one data and here one data, so we can create something like this kind of thing. Okay, and yeah, this is all about the coding part of t-SNE, guys. I hope like it's very simple. Okay, you guys need to understand what is the black box behind this t-SNE, so that this coding part is not going to take more than uh, 10 to 20 minutes. Okay, so we're gonna just load the data set. You're gonna do some pre-processing, statistical kind of thing, and you just need to load the t-SNE algorithm from sklearn, and you just work on it. That's it. Okay, hope you guys have understand. If you guys have any doubt, just ping in the comment section. We'll take up it. We'll solve it. Okay, so yeah, this is all from my side. Sir, is there anything that you need to add, sir?
Yeah, yes.
Okay, sir, I will just
I'll just give overview,
yeah,
a different perspective.
yeah,
Okay,
yeah, sir.
so I'll give fast overview, guys. So uh, mimic this, imitate this application, so that complete this assignment, so that you will be able to build the kind of project out of it, and you can apply t-SNE. So first of all, we had to import the libraries NumPy, Pandas, Matplotlib. Okay, we have to load the data, which we have loaded breast cancer dataset, and then standard scalar t-SNE, which is the like we are going to learn about it and how to. So we have to import that, and then we have to train and test split. We have to import from sklearn.model selection. Okay. Step 2 is loading the data breast cancer data set, which is y and y x cancer.data features and y cancer.target variable, and you have the labels. Okay, there are two different kind of cancers. So here you got the different outcome, target variable and all. Yeah, this is the outcome, features and array for x and y. So, yeah, then we go to step 3. We have to summarize data set, converting to data frames for better summary. So for that, we have to print data set summary and df.describe, and then print n data set shape, df.shape. So this is how you will get the shape and describe summary. So you got the summary and you got the output of shape. The shape is 5, 6, 9, 30. That is the shape. You have 8 rows and 30 columns. Okay. Then we go to step 4, which is pre-processing the data. So we have to pre-process. We have to scale. We have to define scalar equal to scalar, standard scalar, okay, x scaled equal to scalar dot fit, transform x, print in first 5 rows of the scale data. Okay, so you got these 5 rows here, and the output, the x scaled, you have the array. Then you go to the step 5, splitting dataset into optional for training and test purpose. X train, X test, Y train, Y test equal to train, test split, X scale, Y test scale 0.3, random stage 42, X shape, Y shape, you have got the same 569, 30, 569. So train, X train dot shape, X test dot shape, Y train dot shape, Y test dot shape. 3, your output is 398, 30, 171, 30, 398, 171. So applying t-SNE will reduce the from higher dimensional space to lower dimensional space, and we are going to see we are using reducing the dataset to 2 component for visualization. So t-SNE equal to t-SNE and component equal to 2, x t-SNE equal to t-SNE dot fit transform x train. So you got the output x t-SNE. Okay, this is the output. You got X train, that's the output, and X t-SNE, that is the output for that, and Y train, you got the output. Yeah, this is the output for the Y train. Then we have step 7. We will visualize t-SNE results training set. First t-SNE component, second t-SNE component, t-SNE breast cancer data set. So this is how it will look like. So you've seen the after we apply t-SNE, so there's a difference. So we can do visualization before also, so that we can compare both visualizations, so we'll understand properly that what is the difference after we applied the t-SNE. Okay, let's move to the other section. So then we have the 8 transforming test set to visualizing optional. Okay, and this is the output for that. This is the X test t-SNE, and Y test. This is the array. This is the Y test array, and we have got the output. And then this is the test set. There's a difference. There's a lot of difference in training and test, guys. So you can see through visualization. So let's move to the other section.
Yeah, sir. So that's all about the coding part of t-SNE.
Keep learning deeply, guys, with long-term objective function. Let's move to the other session.
Yeah, guys, so this is all about the t-SNE coding session. Hope you guys have understand, right? So you guys need to know about the black box of it, okay? Because like applying t-SNE is very easy, as sir is always mentioned. You guys need to know how it works, what it is, how it is working. You guys can easily do the coding. I will promise you. Instead of going for, so the thing is, you need to learn the black box behind it, okay, and how it works. Then everything is simple, okay? Hope you guys have enjoyed this session, the coding session. So you guys have learned a lot, I hope. Okay, we have learned a lot. We have enjoyed this session. So if you guys have any doubt, just pin in the comment section. We'll take up and we will solve your doubts. And one more thing, guys, please subscribe to our channel, because like every day we're gonna post a new video. So subscribe and press the notification icon so that you can get the new video whenever you can get a notification for a new video whenever we are just posting a new video. Okay. So until next session, bye guys. Take care. We will all meet in the next session. Bye guys.